Okay, welcome back. This is the fourth and final video of the sixth lecture of the engineering design course. This is the slide that we stopped on last time, so we'll pick it up from here. The final thing that I want to do in this lecture is to show you guys one of the really neat features of the function analysis method, and this is what I was talking about in the previous slide in terms of being able to change the boundary of the black box. And in changing the boundary of the black box, you can either include or exclude subfunctions. And in so doing, you actually change the outcome of the design process because all of a sudden your design solution either has to do more if you've got more subfunctions, or it has to do less if you have fewer subfunctions than the baseline version of it. So if you remember all the way back in the beginning, in the very first slide in the lecture, we were talking about sizing the design space, and this is precisely what I was talking about. As you absorb more subfunctions into the inside of your black box, into the boundary of your black box, your product has to do more things. And as you exclude subfunctions, your device has to do fewer things, and the design space becomes smaller. So let me give you an example of how that works. And let's go back to the example that we were talking about previously, which is the headphones. So like, for example, I'm wearing headphones right now. The purpose of the headphones is to convey an audio signal from the computer, which actually just starts out essentially as a digital signal. And the headphones convert that digital signal into sound, which is transmitted to my ears. That sound comes through a cable, like the one that I'm showing here, and that cable is connected to a 3.1 millimeter jack, so it's a physical connection. And one of the requirements is that the headphones fit over my ears. So that was the example that we talked about previously. Now, let me show you guys what happens if we change the system boundary. In this case, I'm going to change the system boundary to exclude the customer need that this solution fits over the ears of the end user. So I've now eliminated that from my solution space. You can see as I move from that to that, you see the change there in the boundary. And now that I no longer have as one of my requirements the need for the system to fit over the ears of the end user, you get a totally different solution. So instead of earphones, you get something that still has this physical jack, this 3.1 millimeter jack that plugs into wherever the sound is coming from. And you still have the system that essentially converts the digital signal and amplifies it into an audio signal, and a system that transmits that audio signal to the ears of the end user. But this device does not have to fit over the ears of the user because that's no longer a system requirement. And so you can see instead of a set of earphones, you get this neat little kind of pocket-sized plug-in speaker as the clear solution to the new design space, where the design space is essentially shrunk in scale because you no longer need this object to fit over the ears of the end user. So I think that's a pretty cool demonstration of shrinking the design space and seeing how the design solution changes in response to eliminating subfunctions from your space. So now if we go back to the original headphone example where we started out before, and let's do something slightly different. So instead of removing the fit over the ears function, let's remove the connect to a signal function. So that function essentially says that there's a wire that has to make a hard connection between the earphones and the computer or the stereo or whatever's making the sound. And so by eliminating the need for that hardwired connection, what I've done is essentially go from earphones that plug into my computer or my stereo to earphones that have like a Bluetooth feature, a wireless feature. So they still receive and amplify the signal. They still transmit the audio signal to the ears of the end user. And here they fit over the ears of the end user, just like in the original example. But the need for a solid connection, a wired connection between the earphones and the computer, is now excluded from the design space. And so again, you end up with a completely different design that has a completely different function. In this case, it's wireless headphones that has some resemblance to the original example, but is actually in many ways simpler. One thing to point out here is if we compare these two examples, the wireless earphones with the wired earphones, notice that by changing the system boundary, I've not only changed how information crosses the system boundary, but also how energy crosses the system boundary. So whereas in this example, I can actually draw the energy in directly from the computer connection because I have this solid connection here, if I change the system boundary, I need to somehow draw in energy without making a solid connection to my computer or my speaker. So whereas this solution, the earphone solution, does probably not require any external power supply or any batteries, this solution does, right? A Bluetooth wireless speaker or wireless headphones require some sort of carry-along battery power supply. So this, again, is just another neat example of how changing the sub-functions that you include and exclude in your design space dramatically changes the end result and also forces you to sort of rethink different attributes of the design problem and sometimes come up with different solutions. In this case, you need a battery to power this thing because you no longer have direct physical access to a computer to draw power directly through a connected cord. So anyway, that is the end of the engineering design lecture number 6. Thank you guys for your attention, and I will see you next time. Bye.